Hello students, welcome to video lesson 7.2. We're continuing our progression into chapter 7. In this section we really get into what the whole point of our ratios and proportions discussion was about in the last video. So we're going to start talking today about similar figures, polygons or shapes that are similar to each other. This is somewhat related to the idea of figures being congruent to each other, which I hope at this point we're somewhat comfortable with the idea of two figures being congruent, right? Two triangles being congruent. We spent a lot of time dealing with that in chapter 4 before we left. So similar figures is just a slightly less rigorous version of congruent, for lack of a better term. So similar figures, they have to be the same shape, okay? Precisely the same shape. And I don't just mean two triangles, okay? Because I can have two triangles that are not the same shape. For example, this triangle and this triangle are not the same shape, right? One's a right triangle. This one looks like it's almost an obtuse triangle. So we can have the same number of sides without having the same shape. So when I say the same shape, it means basically they have to be precisely the same looking shape, but one can be bigger than the other one, okay? Essentially what we have is two shapes that are the same, but one is a blown up version of the other, an enlarged version or a shrunk down version of the other one, okay? So when we have two shapes that are similar, meaning they are exactly the same shape, but one is a bigger version or a smaller version of the other, we use a symbol to say these things are similar. That's sort of like the congruent symbol. Remember that the congruent symbol, if I get back to this guy, the congruent symbol, remember, was an equal sign with a squiggle on the top, right? That was our symbol for congruence. The equal sign basically meant that the shapes were precisely the same, right? All the side lengths were the same, all the angles were the same. So when we go to just being similar, meaning they're the same shape but they don't have to be the same size, we just drop the equal sign and we just use the squiggle, okay? So this squiggle is the symbol for similar to, okay? This shape is similar to this shape, all right? So we will be writing what we call similarity statements, which will involve this symbol here between two names of polygons, all right? Once we have two similar polygons, you guys, we are going to use ratios and proportions from the previous section to find missing information, okay? And not only that, but we're also going to use ratios and proportions to determine if polygons are similar, okay? So here's the main definition of similar, the main two things that need to be true. In order for two polygons to be similar, we need all of their corresponding angles need to be congruent, okay, which means all of the angle measures have to be the same, the corresponding angle measures, okay? So this angle is the same as this angle is the same as this angle, this angle is the same as this angle, exactly the same number of degrees in the two shapes, okay? So corresponding angles have to be perfectly congruent. That makes the two shapes the same shape, all right? And then the lengths of the corresponding sides are what we call proportional, okay? That basically means they make a proportion. They are equal in ratio, okay? So we're gonna see a lot of ratios that are equal to each other, a lot of proportions from our similar shapes, okay? So for example, here in this case, we have four-sided shapes that are similar, okay? And in order for them to be similar, we have to recognize, okay, this angle here, angle B, is congruent to angle H, right? Angle A is congruent to G. Those are both 90-degree angles, as are B and H. C and I are marked as congruent. D and J are marked as congruent. So all of these corresponding angle pairs, 1, 2, 3, 4, are all congruent to each other, okay? And then the lengths of the sides have to all make equal ratios. So if I take the side between the two 90-degree angles in the smaller shape, A to B, and I make that into a ratio with that same side in the bigger shape, AB, that length, and GH, you'll see that here, AB and GH, that has to be the same ratio as going from B to C in the smaller shape and H to I in the bigger shape. Okay, so those two ratios have to be equal, and that also has to be equal to the ratio of CD to IJ and AD to GJ. Okay, so all of these side length ratios have to be equal. They don't have to all be exactly the same size or the same length, but for example, if AB was 2 and GH was 5, then if CD was 3, then this IJ would have to be 7.5. Okay, so they have to make equal ratios. All right. One of the best ways, you guys, to check and see if ratios are the same is actually to go ahead and do your cross multiplying, because if these ratios are the same, the cross multiplication should come out to be the same, right? So you think, okay, what is 2 times 7.5? 2 times 7.5 is 15. What is 5 times 3? 5 times 3 is also 15. So, yep, those are equal ratios, okay, because the cross multiplying gave me the same number for both, all right? Now, once we have polygons that are similar, because we know their angles are congruent, we know the lengths of all their sides make equal ratios, we can find what we call the scale factor. Okay, the scale factor for the similar figures is basically a simplified ratio of the side lengths. Okay, so you can pick any pair of side lengths as long as they sort of match up in the shapes. Okay, so it's going to be helpful in this particular section to look at how your angles are marked, right? So this one has 1 mark, this one has 2 marks. So that side from 1 to 2 would be the same as this from 1 mark to 2 marks. So AC is the same as XZ. And we can make any sort of ratio out of these side lengths and just reduce it down. Now, it is important to note which way you're going, okay? Because 5 over 2 is not the same fraction as 2 over 5 necessarily. So what we would say is, okay, the scale factor from the first shape to the second shape. So notice right here, I have ABC similar to XYZ. So ABC is going to be my top number, my first number. XYZ, those sides are going to be my second number, the bottom number. So what I do is I'll just pick 25 and 10. I make a ratio with ABC as my first number on the top, and then XYZ is my second number on the bottom. That I can reduce down, dividing by 5. I get 5 over 2. So this is the scale factor for triangle ABC to triangle XYZ. From the first to the second, 5 to 2. Okay, 5 over 2. So that's called a scale factor. And you can find it anytime you have similar shapes. All right. Now, in terms of making statements about similarity, here I have 2 names of 4-sided shapes. I know they're 4-sided because they have 4 corners. So this one's like D, E, F, G, 4 sides, D, E, F, G. And then this other one is H, J, K, L. So I have these 2 similar shapes, right? It says this shape similar to this shape. From the names alone, we should be able to figure out what are the corresponding congruent angles and what side ratios need to be equal, okay? In order to do that, it's similar to figuring out information from congruent statements, which we did back in chapter 4. But the order of the letters in the names is very important, okay? Because the first letter, this corner, so angle D, has to be congruent to angle H, because that's the first letter in this name and the first letter in that name. Those have to be congruent. They have to match up in that way. Okay. Also, angle E needs to be congruent to angle J. Angle F needs to be congruent to angle K. And then angle G needs to be congruent to angle L. All right, so I can find 4 pairs of congruent angles just from the names of the shapes. I don't even need any of this stuff up here, okay? This is not necessary because I can see in the names which angles are supposed to match up with which angles. All right, and I can do the same thing for the side length ratios because I just take the letters in order that I see them in the names. So for example, if I pair up D with E, the first two letters of that first name, those need to get paired up with H and J. So that ratio, DE to HJ, needs to be equal to, let's say the next one, EF with JK. That also needs to be the same as, let's say, FG, the last two letters with the last two letters, KL. And then for the fourth one, the only time we get to skip stuff, you guys, is when we go first and last, okay? Because it sort of completes the loop if we go back G to D. So if I go G back to D, that's got to be the same as L back to H. Okay, so just from the names, I can come up with my congruent angles, I can come up with my ratios or my side lengths, and I can find a lot of information just from those names. So you guys, when you write these similarity statements like this, it's very important to note what order are these points supposed to be in? What angles are congruent to what angles, okay? The names matter a lot. The order of the points changes everything if you mix up the order of the points. So make sure that you're matching up the congruent angles, okay? This one with this one, this one with this one, and so on, all right? So a big part of your homework tonight and the practice that you're gonna do is determining if shapes are similar. And if they are, I'm going to ask you to write a similarity statement for them and give a scale factor, okay? So the first question is just going to be yes or no, and if it's yes, you're going to have a little more work to do. So if we look first at these four-sided shapes, which are kind of weird-looking ones, and we want to look at these shapes being potentially similar to each other, I need to first look at my angles. Do I have a bunch of congruent angles from one shape to the other shape? The answer there is absolutely yes. Angle M is the same as angle W. Angle J is the same as T. K and U are both right angles, and L and V are both congruent as well. So I have all four angle pairs congruent, right? All of the corresponding angles are congruent, so that's great. Next question, are the side lengths in equal ratios? Well, I'm just going to start making ratios, and we'll see if we think they're going to be equal, okay? If I take the side from 1 mark to 2 marks, in this case MJ, by the way, if you haven't seen the new Michael Jordan documentary on ESPN, The Last Dance, excellent. First 2 episodes are already out. By the time you watch this, I think the first 4 episodes are out. Go watch it. It's great. The 90s Bulls was like the best. Anyway, okay, I digress. Sorry. MJ is 6. And that gets paired up with TW or WT over here. That's also 6. Okay, so this is one of my ratios. 6 to 6. All right, 6 to 6. If I go to the next side, let's say I'm just going to do the top here, JK to TU. JK goes with TU. That would be 12 to 6, right? 12 to 6. Are these fractions equal? Is 6 over 6 the same as 12 over 6? Well, again, remember, if you want to check and see if these are equal ratios, just do your cross multiplying. 6 times 6 is 36, right? Going that way. And then 6 times 12 is 72. So does 36 equal 72? No, definitely not. Are these two shapes similar? No. These side lengths are not in the correct proportions. They're not in the correct relationships to be similar shapes. So the answer there is no. I don't have to do any more work because those are not similar shapes. They're sort of like the same looking shape, but they're not, like I can't just blow one up and get the other one, okay? Because those side lengths are not in the same ratios. Now, if I go to these triangles over here, again, I want you to first notice that I have an angle congruent to an angle congruent to an angle, and an angle congruent to an angle. So I have 3 pairs of congruent angles over here. So again, I'm going to look at my side length ratios. And it's important in this case, because they've like twisted one of these shapes around, to be real careful about what sides go with what sides. So if I look here, let's say from 1 angle mark to 2 angle marks, CA, in this shape from 1 angle mark to 2 angle marks, that's FD, that's 10. So what I have really is 8 goes with 10. Okay, 8 goes with 10. And then let's see, AB is 12, that goes with 15. 12 goes with 15. And then 16 goes with 20. Okay, so these are my 3 ratios. The question is, are they all the same? Well, in this particular case, I think it's easiest just to simplify each ratio, see if they simplify to the same thing. If they do, then we're good to go. If they don't, then obviously these are not similar. So we can cross multiply. It's just maybe kind of tough to do 15 times 16 in our head, but I think we can maybe reduce these fractions in our head, right? Because 8 and 10 can both be divided by 2, and we get 4/5. 12 and 15 can both be divided by 3, and we get 4/5. And then 16 and 20 can both be divided by 4. 16 divided by 4 is 4. 20 divided by 4 is 5. So we get 4/5. Okay, so what do you notice about these 3 ratios? They're all the same. Okay, they're all the same. So I'm going to say yes for this one. And the good news, you guys, is when I simplify the ratios like that, what I arrive at is my scale factor. Okay, because remember, it says give the scale factor. Well, I just did. It's 4/5. The scale factor from the first shape to the second shape, A, B, C, or whatever, is the same as, or sorry, the scale factor is 4/5. It's the same as that reduced ratio that I just found. So the only other thing I need to do is I need to write myself a similarity statement. So what I need to do is I need to name the 2 shapes. Because these are both triangles, I'm actually going to name them with my triangle symbol. And the first one, it doesn't really matter what order I put them in. Okay, I might just go triangle CAB. Okay, CAB, because that's like 1, 2, 3 on my angle marks. So triangle CAB is similar to, and now this is where it matters. Okay, I'm going to name another triangle over here, but it's important for me to be careful about what order I put the points in, right? What angle is the same as angle C over in this shape? Which angle is the same as C? Well, F is the same, so I'll start with F. Which is the same as A? Because the next letter I went to was A. Well, the same as A in this case would be D, and then what's left, I guess, is E. Okay, so this is my similarity statement. Triangle CAB is similar to, there's my squiggle symbol, triangle FDE. And the scale factor, I'm just going to go SF, scale factor 4/5. 4 to 5. 4 to 5 is my ratio. Okay? So when you decide that shapes are similar, your scale factor is whatever your side ratio reduces to, and make sure you name them with the points in the correct order. Okay? The only other thing I'm going to ask you to do is use the idea of shapes being similar to find missing information in terms of side lengths, okay, missing side lengths in a picture. In order to do this, we're going to have to solve proportions. That's what we were doing in our last section, okay? So here we have 2 shapes. This one's a little bit more complicated just because one is inside the other. But we're going to use the information we're given and the side lengths that we're given to find the value of x. Okay, notice they want the value of x. I'm going to also find the value of y as long as I'm at it, because we might as well. But they specifically want me to find the value of x. So the first thing that I'm looking for, you guys, is I need to have a pair of sides, corresponding sides, where I know both of them. Okay? If I don't have a corresponding pair of sides like that, this process is going to be real hard. In fact, it's going to be impossible. So do we have a pair of corresponding sides in these 2 shapes where I know both of the values? Yes, I have over here, this side is 6, and then this bigger, longer side is 9. So I can write a ratio. And this is where we have a little bit of freedom, okay? And this goes back to those properties of proportions that we were looking at in our last video, where we can sort of rearrange things in a proportion and have it be exactly the same. So it doesn't actually matter if you go from the bigger side to the smaller side, like top to bottom, or the smaller on top and the bigger on the bottom, as long as you stay consistent with the order that you put them in. So I might go smaller shape to bigger shape, 6 to 9. This side is 6, this side is 9. I know that that ratio has to be the same as the ratio of the side labeled X with this side that corresponds to that side labeled X in the bigger shape. And again, because I went small to big, I'm going to go small X that I don't know to big shape 7.5. Okay, and I'm going to try to find the value of X based on this proportion. Now, it is also perfectly okay, of course, if you flip both of those around, right? It's perfectly fine if you go 9 over 6 to 7.5 over X. It's also perfectly okay if you go with the two side lengths from the smaller shape. So if you say, well, the two side lengths that I'm going to try to relate in the small shape are 6 and X, and then in the bigger shape, it's 9 goes with 7.5. That's okay too. It's a little bit more confusing though, so I don't really suggest that one, but it is perfectly okay to do that. So anyway, we have these different options, okay? A lot of different ways we can set up these proportions. Any which way you do it, when you multiply, or if you do the fish method, if you remember that process from Algebra 1, 7.5 times 6 is going to be 45, right? So 7.5 times 6, that's 45. Cross multiply. That's got to be equal to the other cross multiply, which is 9x. Divide away the 9, and the value of x is 5. So I would pick B, the value of x is 5. X equals 5, okay? So I set up a proportion based on what I saw. I solved it for x. And as I mentioned, we could do exactly the same thing for y if we wanted to. If I set myself up a proportion down here, for y, I'm going to use exactly the same first two shapes. I'm going to still go 6 over 9. And then I'm going to go, now I'm going to go y is what I want. I want y over 5 on the top. So I'm going to solve this for y, again, by cross multiplying or by using the fish method, if that's something you're familiar with. We end up with 30 is equal to 9y. Whoops, that's supposed to be a y. Divide away the 9. And I believe we get y is equal to 3.3 repeating forever, 3.3333333. Okay, so we can set up these proportions in these similar shapes just by knowing this side length has to match up with this side length. This side length has to match up with this side length. We can cross multiply and solve, okay? If you have any questions about similar figures, what they are, how to name them, how to decide if they're similar, or how to use their similarity to find missing information, please reach out to me and let me know. Otherwise, that's all I have for you right now, and we'll talk to you soon.